Determine the angle in standard position in degrees in the interval from 0 to 360 degrees, closed on 0 and open on 360 degrees, that passes through the given point. Give the angle accurate to 2 decimal places. The first point is 4, 7. Let's plot this on the coordinate plane. Notice 4, 7 is in the first quadrant. Let's just say approximately here. It doesn't have to be perfectly to scale. Because we're looking for the angle in the interval from 0 to 360 degrees, we are looking for the angle with the initial side along the positive x-axis and then rotating counterclockwise passes through the given point, which is this angle here. Recall that tangent theta is equal to y divided by x, which indicates theta is equal to inverse tangent of y divided by x. So for number 1, we know that theta equals inverse tangent of y divided by x, which is 7 divided by 4. The angle that has a tangent function value of 7/4 is not a nice reference angle, and therefore we'll have to use the calculator, and we're told to round to 2 decimal places. Going to the calculator, we first want to make sure we are in degree mode by pressing mode. Notice degree is highlighted in row 3. If it wasn't, we would highlight degree and then press enter. To go back to the home screen, press second mode, and now we enter second tangent for inverse tangent, and then enter 7 divided by 4, close parenthesis, and enter. To 2 decimal places, we have 60.26 degrees, which is in the first quadrant and in the given interval, and therefore this is the angle we are looking for. Approximately 60.26 degrees is the angle theta. Now remember, the output or range of the inverse tangent function is the open interval from negative 90 degrees to positive 90 degrees, which indicates if the angle is not in the first quadrant from 0 to 90 degrees, the calculator is not going to give us the exact angle theta we're looking for, but we can use what the calculator gives us to determine the reference angle, which we can then use to determine the desired angle. So it is always important to plot the angle on the coordinate plane to verify if the angle does terminate in the correct quadrant and is also in the given interval. For number 2, we have the point -2, 3, which we'll say is approximately here, and therefore we're looking for this angle here. This is the initial side, this is the terminal side, and we have rotation counterclockwise. Notice the angle should be between 90 and 180 degrees. We know the angle theta is equal to inverse tangent of 3 divided by -2. And now we'll go to the calculator. Second tangent 3 divided by -2, close parenthesis, and enter. Notice the calculator gives us approximately -56.31 degrees, which is not in the given interval and also not in the correct quadrant. So there's 2 ways we can use this to determine the desired angle. One way is to recognize -56.31 degrees would have a reference angle of 56.31 degrees, but in our case, it will be the reference angle in the second quadrant. The other option is to sketch the angle given by the calculator and then add 180 degrees. Let's show both methods. Again, we can recognize the reference angle, this angle here, is 56.31 degrees, or approximately, which means the angle theta would be equal to 180 degrees minus 56.31 degrees, which equals 123.69 degrees. This is the angle theta we are looking for. Now, if we did sketch the angle given by the calculator of -56.31 degrees, the terminal side would be pointing in the opposite direction here, which means another way to find the desired angle would be to take the angle given by the calculator and then add 180 degrees. So going back to the calculator, notice if we take -56.31 degrees and add 180 degrees, we do get the desired angle. Let's move along to number 3. For number 3, we have the point 6, -7, which is in the 4th quadrant, let's say approximately here. And again, because we're looking for the angle in standard position from 0 to 360 degrees, we're looking for this angle here. Between 270 and 360 degrees. We also know the angle theta is equal to inverse tangent of -7 divided by 6. And now I go back to the calculator. Second tangent for inverse tangent, -7 divided by 6, close parenthesis, and enter. Once again, notice how the calculator is giving us approximately -49.40 as the angle, which is not the angle we want because while it is in the 4th quadrant, it's not in the given interval. Let's go ahead and plot this angle on the coordinate plane, approximately -49.40 degrees. That would be this angle here, which also indicates the reference angle for the angle we want would be 49.4 degrees, which means one way to determine the angle theta would be to take 360 degrees and then subtract the reference angle of 49.40 degrees, which gives us 310.60 degrees. The other option is to use the angle given by the calculator and then add 360 degrees. Notice if we take -49.40 degrees and then add 360 degrees, we do get the angle we want, the angle theta. So again, there are two ways to go about determining the angle theta based upon what the calculator gives us. I don't recommend memorizing any shortcuts. It's always important to plot the point on the coordinate plane and verify the angle theta. And then finally, for the last example, we have the point -1, -2 in the 3rd quadrant, which we'll say is approximately here, and we're looking for this angle here. Notice the angle will be between 180 and 270 degrees. We also know the angle theta is equal to inverse tangent of -2 divided by -1, which we can simplify to inverse tangent of 2. Going back to the calculator, we enter second tangent 2, close parenthesis, and enter. Once again, the calculator is not giving us the angle we want. The angle of approximately 63.43 degrees is in the 1st quadrant, not in the 3rd quadrant, but 63.43 degrees would be the reference angle in the 3rd quadrant. So let's go ahead and sketch the reference angle, which indicates one way to determine the angle theta would be theta equals 180 degrees plus the reference angle of 63.43 degrees, which equals 243.43 degrees. The other option is to sketch the angle given by the calculator in standard position, where the terminal side would be pointing in the opposite direction of the terminal side of our angle theta. So this angle here would be 63.43 degrees. And therefore, another way to determine the angle we want would be to add 180 degrees to the angle 63.43 degrees, which we already did. So again, the important part about these types of problems is to make sure you plot the point on the coordinate plane and then make sure the angle theta terminates in the correct quadrant and is in the given interval. I hope you found this helpful.